Hi guys, this is Mr. Thompson, and today we're going to be wrapping up our Unit 12 over thermochemistry with some more discussions about enthalpy and what it is and how it applies to reactions. Now, I'm going to tell you guys right now that this can be really confusing at first, both understanding the ideas and also putting it in the calculator. So it's going to be extremely important for you to not just pay attention and write down the information on your notes, but also you need to be listening, and you need to make sure, because I am going to be pointing out stuff in these problems that I'm not going to be writing on the screen, and if you're not listening to me, you're not going to be able to get near as much of an understanding from it as if you were. So with that being said, let's jump right in there and get started with another definition and some more practice. That's exothermic. It will be negative, okay? And you will be given, I'll give you reactions, and then I will give you the enthalpy of individual compounds and elements in that reaction, and your job will be to determine the total enthalpy. So we can use this formula right here. It's basically the enthalpy of the products minus the enthalpy of the reactants. Now I know that seems pretty straightforward, but let's take a look. Here's how I would give it to you. I would give it to you in a chart like this. And this right here is the individual enthalpies of each one of these compounds. Okay. Now I want you to first notice that oxygen has an enthalpy of 0. In elements that are not bonded with anything else will have enthalpies of 0. You don't have to remember that, but do pay attention to the fact that sometimes you're going to see something that doesn't have any enthalpy. And that's fine. This is how we normally find oxygen. It's not bonded with anything. Yes, it's bonded with itself, but that's how it's found in its free state. Okay? Also, I want you to take note that a lot of these values are going to be negative. Okay? When elements bond, this actually releases energy. Them bonding releases energy. So bonding is typically an exothermic reaction. If I'm going to split or break chemical bonds, I typically have to add energy to it. So if I'm going to split up this H2O, I have to put energy into it to break those bonds. So the splitting of H2O would be endothermic. It would absorb energy and split apart. Okay? I know that seems a little weird. The more we work with this, the more you think about it, the better that will get. Let's jump right into an example. I'm going to give you this reaction right here. The more astute of you will recognize this to be photosynthesis. C6H12O6 plus oxygen yields water and carbon dioxide. So what I want you to do is find the overall enthalpy of this reaction. We're going to use the values in this chart. So the very first thing I want us to start with is we need to know which ones of these are products and which ones are reactants. Now your reactants are found on the left side, your products are found on the right side. So we can go ahead and label oxygen and C6H12O6 as a reactant, and then the other two are products. And that's important because we're going to subtract products minus reactants, so we've got to keep them separate. So let's go in and let's start plugging in these numbers, but there's one last thing I want you to pay attention to. One last thing. These coefficients are important. You have to use them. So for instance, when I'm going to discuss the enthalpy of water, I'm not going to have just 285.8. I'm going to have 6 times that, and 6 CO2s. Very important to realize. So I'm going to use this formula right here, and I'm going to plug in these numbers. Now don't panic when you look at this the first time. Let's see what's happening. This first set of brackets is the products. The second set of brackets are the reactants. Right here, this 285 came straight from the chart. I have 6 waters, so 6 times that, and I have 6 carbon dioxides. So I'm going to put those together. We're going to type that in the calculator, and then I'm going to subtract. Well, I've got 1 C6H12O6, so right here I've got 1 of those, and I have 6 oxygens, but of course oxygen is 0, so that doesn't really affect it. And when you type this into the calculator, you get negative 2,779.8 joules. Because this came out negative, that means energy is released and this is exothermic. So if I were to ask you, is this an endothermic or exothermic? This is exothermic. Now, I know that putting this into the calculator can be intimidating, so let me show you real fast how I put this into the calculator. Okay, so if I'm going to type this into the calculator, I'm actually going to make use of these parentheses buttons right here, and I'll show you what I mean. I only need to do it to separate the products and the reactants. I don't need to put every single parenthesis. So watch how I do this. I'm going to start by typing in parentheses, and I'm going to go 6 times 285.8, and I'm going to make that negative. Make sure you keep your negative signs in there. But you have to type it in after you put in the number. I have to type in 285.8 and then hit the negative sign. Okay? Then I'm going to do plus 6 times 393.5, and I'm going to hit the negative sign again. And that's going to be the end of my products, so I'm going to close those parentheses. Then I'm going to go minus, because that's what it says in the formula, and I'm going to put another set of parentheses. It takes it back to 0, but don't panic. You're all right. Now I'm going to type in I'm going to type in 1296, then I'm going to hit the negative. Then I'm going to go plus 6 times 0, which I guess we really didn't need to type that in, but that's okay. I'm going to close parentheses, and then I'm going to hit equal, and that's how I get that 2,779.8 joules. Okay, so let's take a look at another example. All right, I've got this reaction right here. Looks pretty complicated. Looks pretty complicated. I promise you, there will be nothing on the test that will be this complicated. So if you can handle this, you can handle what's going to be on the test. No problem. But it's the same story. We've got this big chart full of enthalpies. Okay? Now, I do want you to notice one thing. A substance being solid, liquid, or gas does actually change this value. Because if you will recall, the value for water was a little bit different. But this was actually for liquid water. Liquid water has a different enthalpy than gaseous water. So that's also important, is to pay attention. Now this time I didn't write any of these on here, but this is going to be gaseous water, so this is the value we're going to use. So same thing. First, let's identify our products and reactants. Here are our two reactants, aluminum metal and ammonium chlorate, ammonium perchlorate. Our products are going to be these four, so there they are. We're going to use this formula, and once again we're going to plug in these numbers. Pay attention to where they came from. Okay, this right here, my aluminum oxide. Okay, this is my aluminum chloride. Notice that my nitrogen monoxide is actually positive. It's weird, but sometimes that does happen. Okay, so no negative sign there. And then I had 6 waters, so once again 6 times that. That was all of our products, minus our reactants. We only had 2 reactants, aluminum metal, which is 0, and ammonium perchlorate, which is negative 295, and we had 3 of them. So put it in the calculator just like before, and that's what we get. Again, since this is negative, this reaction was exothermic. I know this is going to leave some questions on your mind, guys. If you want, feel free to email me tonight. If not, come talk to me in class. As we work out some of these practices, make sure that you're getting and make sure that you're understanding this. I will talk to you guys tomorrow. You have a great evening.